I think Prerit has also joined in. Very good performance on the test 3, students. Congratulations. Even I like the scores for test 1 and test 2. So far going well. Students who have by now not given these tests with respect to these sessions, then please prepare, give. These are good questions. Good final revision towards the end of the examination to cover all these topics, which generally tend to be taken for granted sometimes. It becomes difficult in the exam to guess what the correct answer would be for these questions if you have not seen these questions correctly, because they are to do with gyro instruments. And then, of course, whatever else we are doing at that level. So today we are going to quickly cover one of the most important gyro instruments that you have, one of the most simplest of gyro instruments that you have, on basis of which you get a lot of questions as well. So similar to the previous exercise, I will be giving you a test on this topic that we're going to learn today. The test could be sent to you anytime. So be well prepared. I'll give you at least some time between you preparing and then you're giving the test. Now, if you're going through the textbook, you know the questions are pretty much coming from the text and sticking to the text. These questions and the practice is very important. But I would suggest that you don't solve questions from the textbook before you're appearing for the test. So if you're going through the textbook to revise, just avoid reading any 3, 4, 5 questions you'll have for that topic so that you tend to practice that in the test along with any other question that you will have, right? So that way. Otherwise, if you practice and if you get the same question, then it'll be too easy for you. Just saying, I don't mind you practicing, and if you get the same question, then you are answering it correctly. But then if you're answering, then resolve and correct. Probably there will be one value that is different. So your entire answer could be different. If you find it to be same, like solve and do it. Like, okay, similar question, similar values. I need that from your side. Otherwise, it will be too easy for you. Okay. So remember that as well. So who else? Are we waiting for anyone? Prerit, I hope everyone else, and Prerit, I hope everybody can hear me on a scale of 5. Anyone who cannot hear me can tell me. Gulshan is not here. We are missing Gulshan. Krishma is not here. Suchita is not here. So Suchita is just joining. So what do we know about this? What do we know about turn coordinator? What do we know about turn and slip indicator? You must have seen it as a title in the link that you got. What is it? Chita, warm welcome. I hope you can hear me on a scale of 5. Students, I hope everyone, the readability is fine. Let's get started. It's a very important session, important topic, I would say, because there are 3 or 4 different elements that are required. And here questions can be very tricky with respect to examination. So firstly, let me tell you all the difference between rate of turn indicator and turn coordinator. Rate of turn indicator is a different instrument showing the same things as in rate of turn. What is rate, students? Rate is anything measured against a time reference. Rate of turn is measurement of turn at a fixed rate. The rate is per seconds and the turn is measured in degrees. Now we all know there are 360 directions. They all hold a degree relation. They all have 1 degree, 2 degree, 360 degrees. So rate of turn is measured in degrees. If I am completing a turn of 360 degrees in, let's say, 1 hour, then can I know in 1 hour, if I'm completing 360 degrees, it means that in half hour, I'll be completing a semicircle or a half turn. That if I know the rate of turn is 360 degrees per hour. Now, The rate of turn that you will come across in civil aviation will be called as rate 1 and rate 2. It could go rate 3, rate 4, rate 5 also. But for our aircraft, civil aircrafts, we have rate 1 as the standard rate of turn to be followed. So what is this standard rate of turn? How many degrees per how many, what is the unit of time? So it's 3 degrees per second being the unit of time. So for you to have a standard approved turn for you to maneuver the aircraft, it becomes very important that you are aware that there is something called as a standard turn or a standard rate of turn. At what rate you are turning, it should be measured. Now let's say I'm going on a heading 000 or 360, and then I need to establish myself on a new heading that is 045, and then take that 045 to reach to another point. So what would my pilot do? My pilot would want to make a turn. Now turn could be made on the right or turn could be made on the left. So right now, which side turn will be shorter turn for me? 000 to 045 will be shorter turn. I will go and turn right. Now turning on the ground for an aircraft is very simple. You control the turn using the steering as well as the rudder. The rudder being a primary control surface can move this side or this side and help your aircraft turn. Okay. In air, this is not the only turn that the aircraft makes. This turn is called as yawing, where the nose moves in the horizontal plane. A yawing turn is not in itself complete for the aircraft to turn in air. The aircraft has to do a roll or a bank. Aircraft has to bank as well as the aircraft has to yaw a little bit. Together, the combined effect of roll and a little bit of yaw helps the aircraft turn, maintaining a standard rate of turn that we want. If we want rate 1 turn, then rate 1 turn means 3 degrees per second as a standard accepted rate of turn. Rate 2 will be 6 degrees per second, and you can have higher rates also. Generally, for commercial aviation, rate 1 turn is acceptable, where if you compare 3 degrees per second, 3 6 are 18, 60 seconds is 1 minute. In 1 minute in rate 1 turn, you are only finishing 180-degree turn. And the whole turn of 360 degrees is completed in 2 minutes in a standard rate 1 turn. These terms could be confusing, but I don't want you all to be confused because there's nothing such apart from the understanding of turn. Turn is measured as a rate, as how many degrees am I turning. Now, if I'm turning at a standard rate, 1 rate turn from my 360 heading to 045, how much do I need to travel? How much time will it take can be calculated as per the standard rate 1 turn, for which generally you will have instruments given in the aircraft. Most of your training flights will have standard rate 1 based coordinators or turn and slip indicators. Now, when I say coordinators or turn and slip indicators, rate of turn indicator is also called as turn and slip indicator. And it shows you the rate of turn as rate 1 turn, rate 2 turn, or however the scale is made. It has a pointer. Rate of turn needle it has to measure the rate. And the turn is indicated with respect to whether your turn is balanced or not balanced. So turn with respect to balance or not balanced is determined by the bank angle. But that bank angle is related to whether the aircraft is yawing perfectly or not. So for us to understand the aircraft yaws by the rudder, it means when the aircraft is not having a balanced turn, it could slip or it could skid. Slipping means not having enough. Skidding means having excess. Excess of what? The relationship between bank, turn is very simple to understand. But I have seen that students struggle a lot with it in certain cases with respect to certain questions. So we'll be getting basic clarity as to how should the rudder be controlled or the bank angle be controlled to maintain or come out of a slip situation or a skid situation. That happens with the inclinometer, which is the second part of your rate of turn indicator. So one is a needle that will show you rate 1, rate 2, rate 3 degree turns. How is it beneficial to the student to get this rate information? So the aircraft attitude indicator gives me pitch up or pitch down position, something that you have done session before to this. And then the attitude indicator also gives me bank angles. For an instrument flight, calculating a perfect bank angle is a tedious task. There is a simple formula that will come across where you can decide what is a safe bank angle for your aircraft for a given task. But when you are doing a sophisticated flight or an instrument flight now, all of a sudden, when you want to turn, you won't have time to measure the best angle of bank. So your turn coordinator and the rate of turn indicator, whichever instrument you are using, they give you a shortcut to maintain perfect bank angle. You don't have to measure it. So it's an instrument that makes it easy for you to check if your bank angle is correct or not. And it is just like having a pendulum and centering it in the center of whatever the pendulum is designed. In your instruments, the pendulum is in the form of a glass tube, a curved tube in which there will be a heavy metal ball centered in the center of that tube, aligned with the vertical axis of the aircraft. And when in a straight and level flight, the ball and the aircraft weight both will act parallelly with each other. So whenever the aircraft is turning, the ball itself will turn but be centered. So you will see all these things in the pictures, and it becomes very easy to understand this uh, instrument with respect to just pictures and key points and understanding the functioning of the gyro rotor inside as to about which axis it is made and how is it controlled. Overall, learning rate of turn indicator or slip indicator is also important because it acts as a backup information given by attitude indicator in terms of bank indication. If for some reason you don't get proper correct bank indication from the attitude indicator, this turn and slip indicator, turn coordinator will help you maintain a perfect bank angle if you know how to use it. Today you will be seeing a lot of these things, skills that you will be struggling with initially when you learn flying, or you would be very quick to maintain whatsoever. Some students are very easy to maintain, some students take a little time to come back from a roll or to make a perfect turn or to make a coordinated turn. So there will be a couple of numericals there. They'll talk about, okay, what is the diameter of the turn that you're going to take? Now, you know, turn is going to be 360 degrees. So a diameter could be measured. So it's all about a simple understanding of the same. Whatever my rate of, whatever my TAS is, 360 degrees in 2 minutes rate of turn. So in how much time, how much circumference will I travel? And then I'll use the formula of a circle, radius, diameter, and get answers. So questions with respect to this topic could be theoretical, could be gyro based, could be indication based, could be okay. So questions on this topic could be with respect to the functioning principle, gyro, rotor, what is happening inside. Okay. Or what is happening on the indication, or what is the value of bank angle with respect to the indication, what is the value of rate of turn, are you under the required value of rate of turn, are you over the required value of rate of turn. It becomes huge. Everything could be figured out easily, so you need to understand the different elements involved, and it's a pretty easy concept to learn. So we'll be going quick, we'll be going through important points and checklist about the same things that I've said. And wherever you are confused, you can talk about it. Understand the in-depth functioning of the system, of the balls, the forces. You keep it for your ATPL. But the principles and keywords that are related to main questions asked will be discussed from there. Chances are you might not understand it completely in the go right now when I'm explaining. But when you read it twice or thrice, the 5, 6 lines explaining mechanism, it gets to you. So you don't force yourself much. Just try to keep an open mind and understand keywords to be able to answer the questions where it gets a little more deeper. For you to understand the functioning is to understand what's happening to the rotor at max, or what are the unique elements in the what do we say in the setup of the gyro gimbal mechanism. That's it. What happens to the rotor speed? What kind of rotor is required? Generally, you will see all gyro instruments, rigidity. Rigidity is required high, high, high. So high RPM and this, that, pendulous, this, that, fast reaction systems and all that you have seen in AH. Turn and slip indicator is one such instrument where you don't need rigidity, you need more of precision. So your rotor is moved at a very low RPM. So this is interesting thing to know about your turn and slip indicator, that it relies more on precision. And from there you start learning that okay, it's a gyro that relies more on precision. Higher rigidity will less accurate turn and rate of turn indicator or turn coordinator. The difference between turn indicator and turn coordinator is that turn coordinator gives you a miniature aircraft similar to attitude horizon or the artificial horizon or the attitude indicator. The miniature aircraft also shows you rate 1 degree turn is maintained or not. And in both the indicators, needle type or miniature aircraft type, the inclinometer, the instrument that will show you balance turn, will remain the same. So I'll show you the pictures of both. You should be smart to know the difference between turn coordinator and turn and slip indicator or rate of turn indicator. Turn and slip indicator is a generic term given to turn coordinator or rate of turn indicator. Rate of turn indicator is the term given to needle type indicator, while turn coordinator is the miniature aircraft type. Turn coordinator is the one that is used widely, and it has an advantage. It is more sensitive to turns. And there is a 30 degree orientation of the rotor with the longitudinal axis that makes the turn coordinator more sensitive to turns compared to rate of turn indicator, where there is no 30-degree bend given to the rotor. So that is more instantaneous. Which one? Turn coordinator. This 30-degree bend is a keyword that you should know, that if the gyro has to be like this, then it is 30-degree aligned in one direction to make it more sensitive to turns. And that's the only difference. So focus the keywords, understand what is related to what as we go ahead, and make your checklist and see if you have any questions. I think I've answered your questions already. We have one mentioned TC, turn coordinator, development of turn and band indicator. Yeah, it's a development only. It's a modified version to make it more instantaneous. And is rate of turn indicator also called a turn and slip indicator? Yes, I can say turn and slip indicator is a common term. It is given to rate of turn indicator also, turn coordinator also. It is more close to rate of turn indicator because turn coordinator was an advanced version of rate of turn indicator. Rate of turn indicator, turn coordinator, both have the slip indication given. So that is a generic term only. We don't only get slip, we also get skid. So what is slip, what is skid is very easy to understand with the help of pictures and everything. More questions, students? Whenever your questions are resolved, the chat-based questions, you'll give me a thumbs up, you'll give me Roger, you'll give me understood, not understood, chat method and everything. Now we have common questions like, does the coordinator has 1 degree of freedom? Now you are generally bothered by such questions, and I know that. So it becomes easy for you to categorize all your gyro instruments with respect to how many gimbals are there and how many degrees of freedom are there. One gimbal or one gimbal will generally give you 1 degree of freedom only, students. So rate of turn indicator is a 1 gimbal system. It gives you 1 degree of freedom, 1 degree of moment only. It's a rate gyro. It measures the rate of turn. Remember your directional indicator. We have done a very good session on DGI, directional gyro indicator. Please make sure you are well versed with that also, students. These three are important. So students who have not scored 20 on AH, I hope you have, I've not got feedback on the 2 questions or 4 questions that you have got wrong. So I'm expecting in an proactive update on that from you all. Like, sir, I got this much mark and these were wrong and I've verified it and I've got it correct, or these are wrong, I've not verified it, I'm still confused. Or I have verified it, still not got it and still confused. So I think only 2 students have given me that update out of 7, 8, 9 students appearing for the test. So I'm thinking, why are others not informing? Although I have it, but I want to know. I've taught you how to do it in test 1, test 2. So you have to use the same method in other tests. So some students messaging, sir, I've realized my mistake and it was silly and everything is fine. So I get it. I like, great. If somebody doesn't get back to me, then I don't know what's happening. So please make it compulsory that if you give a test based upon your results, you give me a feedback by yourself the day you get it and the day you are done. And by default, I want you to solve in this strategy always. Okay. After that, your doubts remaining will be solved by me, of course. But this method is very important. You know why? So very good. Chaitanya, I like your update. ये मेरे को अभी टेस्ट के बाद तुरंत चाहिए. जब आप रिजॉल्व कर रहे हो तब चाहिए. Very good. Roger, Suchita, very good. But remember, ये सब मैं expect करता हूँ. Okay. So I'm always in the loop. Good. Prerit, Hemant, very warm welcome, students. I hope you can hear me. 5. Hemant, please try to be on time because sometimes we start. Don't assume we will never start in the first 5 minutes and all. This is just, you have to be sure, because even if you miss the first 5 minutes, then you might not get the context of what's happening, and that could bridge a gap, and that would keep you away from continuing in the live session, and it will still force you to do through the YouTube link, which makes sense because you need to get started. But if the difference is just 2-3 minutes, that doesn't make sense. Why? And we can enjoy doing live also, right? Need of the hour.
Yes.
Yeah. So be careful, please. Otherwise, if you miss that much, if you still continue from here, chances are we'll do mistakes in the exam. We don't want that. So please, students, I wait for you all a lot, right? Sometimes don't get used to thinking, अरे sir late आएंगे. ऐसा कुछ नहीं है. Please, just saying. So Hemant, what's happening? I'll be telling you, we are finalizing gyro-based instruments, and whether you have covered basic gyro or not, post that you will understand this. So right now we are doing TSI. For anyone who has not done gyro also, a little bit also, they can also understand. So study students, I'm giving you keywords, I'm showing you pictures, and that's it. There's nothing much. A lot of pointers and flowcharts to understand though, and time will be required from your end to study and remember things before test. I'll be sharing the test with you all probably same time tomorrow, 4 o'clock, 4:15. And yeah, maybe anytime before that also. So I'll inform you all about the test. But with the test, please don't solve textbook-based questions. Just study from the textbook, because I'm going to give you from textbooks. So it's pointless for you all to give that. Like, it will be too easy is what I'm saying. So yeah, if you're copy pasting, then make sure you solve it and come to the correct answer, and not letting your mind think that you have already solved it. So that one honesty you need to do initial stages, okay? Everyone. So that's it. Write down first definition we'll talk about. Let's talk about rate of turn indicator. Now the first question would be, what is the purpose? Hands up. I'll give you a chance to answer, students. What is the purpose? I've explained you the things, right? Now you tell me. What is the purpose? What do you think? Yes, Nukul. Quickly. Rapid fire questions. Okay, students? Nukul, you're on mute.
So the rate of turn indicator used to measure the rate of change of angle.
Okay. Muskan?
Sir, the rate of turn indicator, it measures the rate of turn about the vertical axis.
It measures the rate of tan about the rate of turn about the vertical axis. Okay. Prerit?
Sir, it shows the turn through bank for the specific period of time.
It shows turn through bank through specific period of time. Okay. Okay. Good understanding so far, students. Who else can give me an answer? Prerit, Muskan, Nukul, very good. Students doing it offline, I'm hoping you are also coming up with answers. So whoever is doing offline, like students are gonna do, whoever has missed it, right? He's gonna do, like Aditya is gonna do. So you should send me answers in real time whenever you are studying. Make it live for you. You just text me answers instead of Zoom chat or your questions and doubts and keep them part. Nukul, very good. Oof. Okay, Suchita, go ahead.
So the purpose of rate of turn indicator is to measure the rate of turn about the axis, and in order to find if the turn is balanced or not, the change in the turn if it is in limits or not.
Students, it measures, okay. We can say it measures rate of turn about a vertical axis. This about a vertical axis is pretty simple. Aircraft will have your vertical axis going through the center like this. Okay. If you look at it, yes, it is a rate gyro used to measure rate of turn through bank. So the vertical axis going through the center, like exactly in the center, the turn is measured about this axis like this. Okay. But the turn in itself will not be just in the yawing plane. It'll be in the rolling plane also, as in you roll or bank and then you also turn. So the turn measured is in the horizontal plane only, students. But to turn, you have to bank, and your bank helps you control your turn. Remember that, okay? Measures rate of turn about a vertical axis via a rate gyro. So there are two elements in your rate of turn indicator. It measures rate of turn about the vertical axis. Now you understood why vertical axis, very simple to understand. Via a rate gyro. A rate gyro measures rate of turn. DGI, is it a rate gyro or not? A good question for you to come up with in the back of your mind. Now, rate gyro measures rate of turn. Rate of turn will be you write down standard rate 1 turn value is 3 degrees per second. That is 180 degrees per minute, and a complete 360-degree turn in 2 minutes. So your standard rate 1 turn makes you finish 360 degrees in 2 minutes. Note, standard rate 2 turn is equal to 6 degrees per second is equal to 180 degrees 30 seconds, that is half minute, and 360 degrees in 1 minute. So 1 minute turn is not rate 1 turn. This is a beginner's mistake where we get confused without focusing enough to differentiate between the two. Your differentiation should be rate 2 turn twice rate 1. That should you do. And rate 1 is 3 degrees per second. So rate 2 would be twice of rate 1, that is 6 degrees per second. So half. It's twice as fast, so half. Generally, your Cessnas and everybody will be designed to have rate 1 turn. Sorry, I think something went in my eye. Now you know these turns. Easy. You understand the turns. Now let me give you a numerical. Okay. Sandeep, how do you read?
Sir, I read 5. Sorry for joining you.
No worries. Sandeep, I'll just text you. You follow that instruction. Now, it is very important, students, to understand the base, what we have discussed, and now what you are studying now in point, because it's going to be pretty simple if you recollect with all that I have told you, or when you can attach it with what I'm saying. Yeah. Sure. So let me give you a quick numerical that could come with respect to these things. All right. It's a very simple numerical, but then again, you have to be very careful with what I'm showing you right now. Okay. But before that numerical, I also want to show you the other purpose of the rate of turn indicator. Purpose 1, and then I will give you purpose 2. Purpose 2 is to help you stay on a correct bank angle, or to give you a direct indication of the state of a balance of a turn. Is your turn balanced or not? And what is the state of balance of your turn? Is it balancing? If your turn doesn't balance, then it could either cause the aircraft to skid, or it can cause the aircraft to slip. Slip or skid will indicate the aircraft turn is not balanced. Purpose 2 indicate state of balance of a turn, and this is done via an inclinometer. This inclinometer is a glass tube with two markings and a ball in the center, and it is filled with liquid. The liquid is to dampen the oscillations because this ball has to behave like a pendulum. Only then it works. Now, students, it's pretty simple. If my aircraft is flying straight and level, my ball will be in the center. I will not have any turn. What is my turn and slip indicator looking like? My simple turn and slip indicator will have a pointer, left, right, and indications. And then it will have an inclinometer like this with a solid black ball. So the rate of turn indicator is this. This pointer will be attached to the frame of the gimbal, ring, gimbal, however you call it. It will show you right or left bank against the indexes. There will be indexes, rate 1, rate 2, rate 3, or just rate 1, or just rate 1 and rate 2. So this will be rate of turn, while this will be balance turn, or this is our inclinometer. This is rate of turn indicator, while the one on the right that I'm making right now, okay, this has a miniature aircraft in the center. It has two indexes like this, and it shows you what minute turn it is, above or below. 2 minute, 1 minute. It's 2 minute turn means rate 1 turn. So your aircraft has to align with this index simply. When your aircraft wing can align with either of the single indexes, it means you are trying to match the correct bank angle. So you are doing your job. But sometimes when your turn is not balanced, then that could be represented by a inclinometer like this again. Same. So here, this shows me rate of turn, and this is the inclinometer. The only difference being here it is needle, and here it is miniature aircraft. And the second difference would be 30-degree alignment between whatever the rotor. This will have the 13-degree. So this is the modification. It is better than the earlier one because just have to coordinate the turn, nothing else. More instantaneous. So the one on the right is your turn coordinator. The one on the left is your turn and slip indicator. We can simply say the same. And they both are turn. They both are turn and slip indicators. This is rate of turn indicator here. This is also commonly called as turn indicator only, students. So don't worry about the names. TSI is a generic name, you could say, or TSI will be more close to rate of turn indicator. Turn coordinator is also TSI, a modified version of rate of turn indicator, a 30-degree alignment between the rotor and the axis. This much you keep in mind as keywords. And this is more readily available in aircrafts. The other older one will have needle for indication. The one with needle of indication can have multiple rate of turn indications shown. Your turn coordinator will generally have just one. It would be mentioned whether it's rate 1 or rate 2. 2 minutes means rate 1. 1 minute would mean rate 2, and like that. The point of concern for the student should be to not confuse turn coordinator with artificial horizon or attitude indicator because of the miniature aircraft. Okay. Now let's talk about turns. Let's talk about turns. Turning left. Okay. In both cases, if I have to turn left, my needle in the purple one will also show me a pointer here on the left side. And my ball will be in the center. On my turn coordinator turning left, my aircraft alignment will be like this. Like this. And it will align with the index and the ball will be in the center. So ball being in the center, the inclinometer will not go like this, Either the needle will go or your aircraft miniature will get inclined towards that. So this is the index. Here, aligning with this blue index, the wing, it means you're following a standard rate turn of 2 minutes, 3 degrees per second you're turning. And which direction? It is left. The direction of bank going left. Rolling towards left, banking towards left, the same thing. Remember, in both cases, the ball is in the center of the tube, and the tube has two vertical lines between which you should center the ball. So this is a left balanced turn. So left means your turn or rate of turn indicator also shows you the direction of turn. Another purpose. Some of the notes, some of the questions could say the purpose of turn and slip indicator to show you the rate of turn and the direction of turn, as well as a state of balance of the turn. So left shown by the gyro, balanced turn shown by the inclinometer. Okay. Here on the turn coordinator, left shown by the miniature aircraft and balanced turn shown by the inclinometer. So in both situations, inclinometer is the same. And for a balanced turn, the ball has to be in the center. Okay. Chaitanya, what's on your mind?
Sir, balance turn is the rate 1 turn only. Sir, how do you read?
Read you 5.
Sir, I was asking that the rate 1 turn is only the balance turn.
If you are required to make a turn with respect to rate 1 turn, and if your instrument is also designed to make rate 1 turn, which is turn coordinator, then following a rate 1 turn will only result in a balanced turn. You need 3 degrees per second, and that is what your intent would be. So in order to follow 3 degrees per second, students, how much should be your bank angle? That can be calculated as per the TAS. If you know that bank angle, then you bank the aircraft. Let's say if you know the bank angle, then you bank the aircraft by that value to the left to initiate a standard rate 1 turn on the left. When you're initiating that turn, when you know the angle of bank and you're initiating as per the attitude indicator, when you measure the bank angle, you make sure the ball stays in the center of the inclinometer. If the ball stays in the center of the inclinometer when you have applied the bank, as a pilot would also be taught to apply equal rudder in the right direction, then you have a balanced turn. And in this case, when your instrument is designed for 2-minute rate 1 turn, then you will be following a balanced turn of rate 1 turn only. In case your instrument shows you a left turn and the ball is inside the circle, then it is a left turn with slip. This is no more a balanced turn, and this situation means the aircraft has slipped. Why slipped? The ball moves in the direction of the turn. Whenever the ball is in the direction of the turn, it is slip. The same situation, my turn coordinator in this case, it will have markings like this. Its idle aircraft should be like this. But the inclinometer will show me the ball here. It means it's a left-hand turn. I'm trying to follow a rate 1 turn, but my turn is not balanced. It's an unbalanced turn where the aircraft is experiencing slip. When we say slip, what does it mean? It can also mean that the tail of the aircraft is moving towards the center of the turn. The tail of the aircraft is also moving towards the center of the turn. It can also mean tail of aircraft is moving towards center of turn. When it comes to tail, they are going to talk about rudder because the movement of tail means moving the rudder to influence the tail. Okay. Same. Tail of aircraft moving towards the turn. But the indication is different. Here, it is showing you on the index with a needle. On the turn coordinator, it is showing you just the one index for a 2-minute instrument. So always be on the lookout on a turn coordinator. What kind of instrument it is, rate 1 turn, rate 2 turn, or whatever else. Now, as you might have imagined, skid is opposite, okay? And you are trying to turn left. So your needle will show you this point properly. But your inclinometer will show you ball out from the center of the circle, or the tail being out from the center of the circle. So it becomes left unbalanced turn with skid. When I say skid, it means tail moves away from the center of turn. A very simple explanation, but you will see you will be confused a lot if you don't develop clarity for the final time right here, right now in the class itself. That is the whole purpose right now. You need this clarity that will never be wrong, because right now it's all about left turn. So think about the direction of turn and see where the ball is. If the ball is in the direction of turn and out of the square, it obviously will be out of the 2 vertical lines. So these 2 vertical lines are very important for us. If it is in the direction it slip, it's in the direction away from the direction center of the circle, center of the turn, then it is skid. Aircraft tail moving towards the center of the circle, slip. Away, skid. It has to be in a specific position that gives me balanced turn. Anything towards the circle, slip, skid. Second thing, you can talk about slipping and skidding. If you confuse yourself, then let's say I'm walking. Let's say I'm walking and I slip like this. See, I'm walking and I slip. I'm slipping towards where I'm walking. That is slip. And skidding is when I'm running like this and I skid on the outside. It's always the same case. Aircraft can slip, aircraft can skid, similar to how we slip sometimes inside or we skid sometimes outside. So slipping is towards the center, skidding is away from the center. Simple. You skid when you're taking a steep turn on a cycle, you skid outside. And you slip when you're slipping inside. So on a vehicle, you don't experience slip much. You experience skids. Slip is very difficult on that when we are banking a vehicle. But with respect to aircraft, it is possible. So I'll also show you the other turn coordinator here. The turn coordinator here would have, remember, it will have something like a horizon. And it will be aligned. And my skid would look like this. Ball would be outside. Further the ball, more the amount of skid or slip. Same, left unbalanced turn with skid. Same. Instruments will show you the same things only. Something wrong, right, students? I think all stations, how do you read?
Radio
Medium
size.
How about the video? Is it fine? And screen, is it fine?
Often, sir.
Yes, sir, it's fine.
Okay, good. Quickly go through this point, see if you have any questions. Quick, quick, quick. Yes, Chaitanya.
Sir, if we are doing an unbalanced turn, then we are slipping. And if we are also doing an unbalanced turn, then we are skidding also. Sir, what is the sole purpose of slipping and skidding? Like what movements will we do when we will skip and when we will skid? Like both are unbalanced turn.
You'll get the answer to the question in the next point that I'm giving. So students, Chaitanya is asking a very good question. Sir, मेरा slip होगा क्यों? मेरा skid होगा क्यों? What would give rise to a slip or a skid? Now we know if our turn is balanced, it means we are doing the perfect thing. Now remember, the relationship that I told you was that you can calculate a bank angle and maintain that bank angle. So if your bank angle is not enough, it could result into a skid or a skip. A skid or a slip. But if your bank angle is constant, then what is it that could vary? It is your rate of turn in itself. So your relationship could be either your rate of turn is slow or fast while you're experiencing slip or skid, or your bank angle is too low or too high, so you're experiencing skip or a slip or skid. And if you have applied too high or a rudder or too low or a rudder, that could also account for a slip or a skid. All three different factors can be responsible for the aircraft to be unbalanced from the aircraft's perspective, provided a TAS is maintained constant. So if your rate of turn is constant, TAS is constant, then bank angle could be varying. If your bank angle is constant, TAS is constant, then your rate of turn could vary, and that could result into slip or skid. So for you, the only way you can come out from an imbalance is to manipulate the rudder. Students, is there a problem in readability?
Negative, sir.
Fine. So you can play with your rudder, and most of the times it's not just the rudder, but the aileron also. But here we will only be talking about rudder because aileron generally for roll you have applied its differential. Rudder is something that you can manipulate. So a simple way to understand these things by a simple concept where you understand when it comes to your rudder pedals, you have two rudder pedals, right rudder pedal, left rudder pedal. Now, when you're on a left turn, the ball being towards the turn will mean you are slipping. So when you are slipping, the ball is on the left in a left turn. So in order to create a balanced turn, you apply the left rudder pedal. So you step on the ball is the key word given to students abroad during their initial flight training. So if you're skidding, you press that side of the rudder. If you're slipping, you press that side of the rudder. Now, this example that we are taking is with respect to a left-hand turn. On a right-hand turn, slip will have the ball on the right side, so you'll have to apply the right rudder. That is how you can come out. So why have you applied right rudder is something that you need to know. You have applied right rudder. Why? To increase the bank angle. So what happens in a slip? The bank angle is not sufficient if the rate of turn is constant and the TAS is constant. So if the bank angle is constant, then the rate of turn could be high in a slip. So what are these points? I'm giving you these points in sequence, write them, and along with Chaitanya, everybody else will have an answer, which I've already given. I'll again give it to you in writing. So what do you have to write with respect to this? Okay. First, I want you to do this. To find a correct bank angle to maintain rate 1 balanced turn. Okay, how? In equation, let's take a TAS of, let's say, I'll take the example from textbook only. TAS 150 knots. TAS is 150 knots. Find out the approximate bank angle to maintain a rate 1 degree. So the rule is 10% of TAS plus 7 degrees will give approx bank angle to maintain rate 1 turn. So what is 10% of TAS? 10% of 150, you use your scientific calci, you will get 15 plus 7 degrees, you get 22 degrees. So you'll have to move 20 degrees, 22 degrees to the right to make a rate 1 turn to the right, or 22 degrees left to make a rate 1 turn to the left. But in flight, you cannot make these calculations. You can make it pre-flight. For instrument flight, it's not practicable. Accuracy is good enough when you're talking about 10 knots to 250 knots. Beyond that, the accuracy for this formula is not too great. So for you to focus on a balanced turn, not worrying about the quantity of the turn, but quality, you just align your aircraft, if you have a turn coordinator, and make it align with the index, the first thing. You will be equally slowly be applying pressure on your rudder, okay, for the turn. And if your ball is in the center, then once you have aligned, you stay still, your aircraft will automatically be turning 3 degrees per second. If you have to make a 45-degree turn, so 45 divided by 3 will tell you for how many seconds you have to turn. Probably for 5-10 seconds if you turn, for 5 seconds 15 degrees, so 15 seconds. If you turn left, you have aligned with a 45-degree turn. In our example from the previous example, heading 360000, I'll take how much? I'll take 15 seconds to go to 045. So I'll have to level out of the turn within 15 seconds. I can understand the timing factor also with respect to this. The only problem happens when your turn is not balanced. You are doing the best that you can, but sometimes insufficient rudder can be a reason. So how to understand that concept? Keep in mind, you will be seeing it right now if you have not yet understood it directly. Okay, students? So first, remember how to find the bank angle. 10% of TAS plus 7. How to find a bank angle, approx bank angle for speeds between 100 knots to 250 knots. Okay. Second thing, let me tell you about this. Ball not centered will mean turn is out of balance. Use rudder to balance out the turn. Okay. Write down for a, write everything, okay? For a right balance turn, okay? When experiencing right turn slip or slip when turning right, okay? rate of turn is too low. Underline this. For a given bank angle. Okay. Rate of turn is too low for a given bank angle, or bank angle is too high for a given rate of turn. So the direct answer to Chaitanya's direct question, on a right turn, if you're slipping, your rate of turn is too low if your angle of bank is correct. Or if your angle of bank is incorrect, rate of turn is fixed, then your angle of bank is too high. So too high angle of bank, too high angle of bank will result into slip. Too high angle of bank will result into slip, or too low rate of turn will result into slip. Write down. Therefore, too high bank angle in direction of turn causes slip, and too low rate of turn causes slip. The third factor, okay? The third factor, so this is number one, this is number two. Two elements out of the three done. I told you there will be three ways, three factors. The third factor would be rudder. So what is happening to the rudder also explain. This is very important, students. Very easy. But it is not easy if you don't do anything with it. And the third factor, I'll tell you, okay, in a right turn, if your right rudder is inadequate, a slip will result. So this is about a right turn. You'll write down inadequate right rudder. Inadequate right rudder, as in right rudder is not sufficient. So what will you do? You'll apply adequate right rudder, as in you'll increase the force on your right rudder to come out of slip. Simple. The slip is in the direction. So what was taught to you? Press on the ball to create a balanced direction. Press the right rudder pedal. You're fixing the situation by default. So what you already knew, now you're learning in a different perspective, that pressing on the ball is actually teaching you to press the rudder in the direction where the ball is. So a slip, press the right rudder, come out of it. Why is slip happening? Rate of turn is too low, or the bank angle is too high, or rudder is inadequate during a turn. Play with the rudder, fix your issue, balance the turn, be a good pilot. Simple. Rudder is spring action, basically. If you want to understand the feel of rudder, as long as you have applied the rudder, the aircraft will give you the required yaw. You remove the rudder and the aircraft will try to come back straight and level, wherever its straight and level was with respect to the turn also. So you have to keep a constant pressure on the rudder and control it and feel it. So yeah. Inadequate right rudder applied during right turn causes slip. Students, say it's very simple, okay? If you press the right rudder, the rudder will move like this. Be very careful, okay? Pressing the right rudder, the rudder will move here. The rudder moving here, what happens? The aircraft will also turn in the right direction. So rudder moves in the direction of the aircraft only. Don't think it's differential. Only ailerons are differential. And when it moves like this, yaw causes roll, roll causes yaw is a function that you need to remember. Now, if my turn is not enough, then I apply more rudder and my turn becomes enough. The rudder applied will always be in the direction of turn. Also remember that. It will make your understanding much more simpler. If you want to turn left, then press the left rudder only. If you are slipping, then your left rudder is inadequate. Simple. For you, that would be the main way you would come out from it. And if you are skidding, what would be the meaning? In skidding, your left rudder is too high. So how do you come out of it? You press in the direction of the ball is directed on the left side in a right turn in a skid. So you'll press the left rudder. Instead of releasing the right rudder, it's not a spring mechanism. The effect is like that for the aircraft to come back to its original. So instead of pressing more on the right for a skid turn, so what happens in the skid turn? Exact opposite. The bank angle is too low in a skid, or the rate of turn is too high in a skid, or the applied rudder is too much. So you apply the opposite rudder, that is the left side, where the skid ball is. So on a skid during a right turn, you apply the left rudder. On a skid during a left turn, you apply the right rudder for a balanced turn. For a slip in a right turn, apply more of right rudder. For a slip in a left turn, apply more of left rudder. Anybody could play with words, students. Come on now. If you have understood it, you can in fact create more questions than paper setters, you know. Are you sure you're aware about these things now, students? It's very nicely explained. Everything is covered. So for a right-hand skid, the opposite things are working out for you. For a right-hand balanced turn, when experiencing right turn slip, rate of turn is high. Here you write down when experiencing skid on a right turn, what will happen? Rate of turn is too low. Second point, correction, rate of turn is too high is the first point. And the second point would be bank angle too low. Therefore, you can say that too low bank angle can cause skid. And you can say too high rate of turn causes skid. And the third point will be very important. Too much or excess of right rudder during a right turn causes a skid. Write down the remedy. Apply more of right rudder by pressing on right rudder. Simple. The remedy for skid is apply less of right rudder by pressing on left rudder. Remember that. You can release your pressure, understood, but pressing on left rudder is important. Press on the ball. That is the indication. Remember that. Please study through this. This sums up everything that you have to cover. Just one numerical and basic construction of your gyro with respect to 2-3 key points, and you're done with the turn and coordinator. Of course, everything takes time. It's not that easy, but you're done is what I'm trying to say. I'll show you actual pictures and some keywords. Then just you study once, focus on things that not covered, mark it, see what's there, what's not there, share screenshots with respect to what you've been confused with or not, and be ready for the test. Get done with the test, master this concept, move on to the next concepts. 1 by 1, 2 by 2, 3 by 3, however it comes. 1 by 60, you're thorough so much. AH, you're thorough. TSI, you'll be thorough. Quickly, you'll be thorough with everything. 1 by 1, 1 by 1, 1 by 1. Remember, for that, your base needs to be strong. Doubts need to be clarified. You have the resources. Don't waste your time. If you have time, study through those resources. Or studying just 2 hours, 5 days a week is not enough. If you're thinking just live lectures are going to help you get there, nothing else will you do, then you're very wrong, students. Right now, that is not the possibility. But if your base is strong and if you're thorough with what I'm doing in the live lectures on the basis of what you've studied, then you are in the same boat like everyone else. And the boat is that we are targeting the June session only in these sessions. So you have to do both. You have to do this and then you have to study from your lectures. The students willing to give NAV in June, now you know you have to study the ones that you have, lecture 31, lecture 32, 33, however, not all are equal length. And then simultaneously also have to attend the live lectures as we are polishing concepts. If you think your basics for the live lecture is not covered, then you can skip that, cover the basics, do that. Then again, there will be 2 backlogs for you. Thinking backlog, it worries you, right? It's not like that. Just study. Give 8 to 10 hours minimum and you are there. Lecture speed you can increase using the playback speed. And it's not like you will be doing it for the first time for all lectures. I mean, basics are covered live. That is the most important. The strategy is super fantastic only if you follow it, is what I'm trying to say. The miniature aircraft in this aircraft is also in this instrument for coordinator is also adjustable, and it should be adjustable to align with the horizon. Okay, students, remember that. Let me show you a couple of pictures with respect to how the instrument looks like. Now, these are 3 gyro instruments showing you a right turn. Okay. The attitude horizon turning right, you can see some bank angle, a little bit of pitch up altitude. The DGI, this is the directional gyro. Because you're turning right from 000, you're going to 030040. So the card, the rose line will be moving to the left. Don't confuse that. This is one very important picture that I am sharing with you all where relative motion can confuse you initially when you're doing instruments. So on a right turn, your DGI card is moving to the left side. Only then it will make sense to show you the proper heading on the aircraft index, which is fixed. So the rose line changes. So you need your directions to increase. For your directions to increase, the card should move anti-clockwise. Only then your directions will increase because the aircraft is fixed. If the aircraft was moving, card was fixed, then the aircraft would be moving right in the direction of your turn. So when it comes to DGI, the turn of the card is opposite in the direction of turns for you to see realistic turns. But this is your exact turn coordinator. This is not a turn and bank indicator. It's a coordinator, 2-minute, coordinate 1 turn. So the index is just showing you the perfect bank angle for that perfect speed, whatever the bank angle was. In your instruments, no pitch information will be clearly given because sometimes some people can confuse the miniature aircraft to be attitude indicator and they might rely on this for pitch information. So instrument will clearly show no pitch information. So in a right turn that we took example of right now, three instruments are gyro-based, DGI, attitude indicator, and rate of turn indicator along with inclinometer or the turn coordinator in this case. See this. On the left is your turn and slip indicator. On the left, turn rate of turn indicator. Now turn and slip indicator more close to the rate of turn indicator definition, like I said. And then the other one, turn coordinator. Both could have a generic word saying rate of turn indicator also, or turn and slip indicator also. So now you understand the needle type can be referred to as turn and slip indicator, the one on the left, one on the right, turn coordinator. It will always mention. The turn and slip indicator, the needle type could be fixed with rate 1 indicator. So here the index is just that one, or it could be with multiple indications also, rate 1, rate 2, and so on. They give you the same information, students. Now look at a level flight in a turn coordinator. T straight and level index is the one aligned with your horizon, and turn index is the bottom arrow. Inclinometer is the center tube. A standard right turn which is balanced and a level flight which is balanced. The ball is in the same side and the bank of angle is also represented. You don't know the value, but you know it is balanced as long as the aircraft wing aligns with the turn index. So one is a level index, one is turn index, one is inclinometer, and one is the miniature aircraft. Remember, here also you're viewing the aircraft from the tail. Remember that. You're viewing the aircraft from the tail, from the rear in this case. Now this is the right-hand turn, an example of which we took. See the tail. I was talking about the tail. The turn in the center, the turn on the right is a coordinated turn. Okay. With respect to this coordinated turn tail, the skidding tail is away from the center, more towards the left, and the slipping turn is more towards the center of the turn. So your tail is changing. In order for you to move the tail more toward the right, you'll apply the right rudder. As in, for your aircraft to turn right, you'll apply the right rudder. So a slipping turn, a skidding turn, and a coordinated turn on the right. Look at the inclinometers and look at the aircraft, how it looks from above. The one on the extreme right, students, the one on the extreme right is a right turn which is coordinated or balanced. The one on the extreme left is slipping. Understand the ball in the inclinometer is towards the center. The tail is comparatively towards the center. What will you do to come out of it? Wherever the ball is, apply that rudder, apply right rudder. It means your slipping could be because of inadequate right rudder or low rate of turn or high angle of bank. Two more things you need to know in your memory right now. Skidding turn, too much of rudder could be applied, less bank angle or high rate of turn. So I need to reduce the right rudder by applying the left rudder. Automatically, I'll counteract the force of the right rudder. So with slipping, you can use the word slipping in, and skidding will skidding out. Slipping in, ball in the center of the circle of the radius of the turn. Skidding means out. All keywords are there. You just need to have clarity. Any questions so far? Feel free to ask. See if all your questions are answered correctly. Formula. Bank angle that you need is equal to 10% of TAS plus 7 degrees. Okay. Second, circumference of circle is equal to 2 pi r or pi d. Okay, where pi is equal to 3.14 or 22/7. R is equal to radius and d is equal to diameter. Okay. Rate 1 turn is equal to 3 degrees per second. (360° in how much, students? In 2 minutes. It's a 2-minute turn. Now the equation that I want to give you all is a very simple numerical for a rate 1 turn. Similar applications you can make for rate 2 turns, also be on the lookout. Okay. Flying at 360 knots, find turn diameter for rate 1 turn. Solution is pretty simple, students. Look at the solution. Okay. It takes, my aircraft is here, and it takes for my aircraft to finish one circle with respect to a certain radius. How much? 2 minutes for a rate 1 turn. Okay. A complete turn of 360 degrees. Now I'm traveling at what speed? 360 knots. And in 360 knots, I am covering a total distance. Just look at it, how they are solving it, of 360 degrees. So in 2 minutes, just think about it, okay? 2 minutes. How much distance will I be traveling? How will you determine in 2 minutes how much distance will you be traveling? In 2 minutes, you are covering 360 degrees. Now the length of the circumference of the circle measured point to point, 360 degrees circumference, is the length of the distance traveled by my aircraft in these 2 minutes when I am finishing a 360-degree circle. And the length of the outside of the circle itself is circumference. And if I know circumference, I can find out the diameter or the radius of a turn. So my focus should be 360 degree, 2 minutes, 360 knots. So 360 degree minutes, 360 degrees means you're traveling the whole circumference in 2 minutes. So what is the distance of the circumference of the circle for your turn right now? It's simple duration equation that you put on the scientific calci. So tell me, in 2 minutes, how much distance am I traveling in terms of nautical miles? This is the circumference. And through circumference is equal to pi d, my diameter will be pi. My diameter will be what, students? It will be circumference divided by pi. Or my diameter here would be, very simply said, circumference divided by 22 into 7, like this. If I do cross multiplication. So you need to find circumference, and your circumference, students, is nothing but distance traveled in 2 minutes in rate 1 turn. If it would be rate 2 turn, your values would change. So who can tell me at 360 knots in 2 minutes, how much distance am I traveling? What is my circumference? And as per my formula for circumference, What is the diameter of a turn? All you had to use in your logic to solve a question like this is rate 1 turn value to determine 360 degrees finished in how many minutes? Those 360 degrees are circumference, length, the distance traveled. And distance traveled can be counted in the way the rate of turn is 2 minutes, 1 minute, 2 minutes. So how much distance am I traveling in 2 minutes? I'm looking for answers. Students, Hemant, Muskan, Prerit, Vishnupriya, Nukul, Chaitanya, Suchita, Jyotsna. Answer. 2 minutes length. What is that length? What is the circumference of the circle? Quick. In your CX3, put duration 2 minutes and speed 360 knots. You will get the distance. It's that easy. Only Muskan is ready with her answers. Why is everybody else not ready with the answers? Now Jyotsna is ready with the answer. Chaitanya, what's your answer? Students, raise your hand. I'm asking you all questions. We're taking a lot of time. मैं 3 बार रिपीट कर चुका हूँ, अब तक आंसर्स नहीं मिल रहे हैं मुझे. Chaitanya, Vishnupriya, Hemant, Prerit, Suchita. How to do it? CX3, duration, speed, distance. Put duration 2 minutes, speed 360 knots. You will get the distance. Chaitanya, are you doing it?
Yes, sir.
आंसर चाहिए, इतना टाइम नहीं लगना चाहिए. कहाँ है CX3? Students, you all have digital links, right? It's on the phone. वैसे भी आप लोग फोन के साथ ही बैठे रहते हो. Hemant, play around with CX3. Tell me duration, speed, distance. I just need the value. How much will I travel in 2 minutes to get the circumference so I can find the diameter? Prerit, Suchita, Vishnupriya. Yes, Muskan, what's the answer?
Sir, the distance is 12 nautical miles.
12 nautical miles in 2 minutes gives me circumference. Circumference is equal to pi d. Pi is equal to 22 upon 7 into d. My circumference is 12. So I get this equation. The question is asking me diameter. So diameter will be 12 into 7 upon 22 is equal to the diameter. If they would have asked me for radius, then I would have done diameter by 12. So let's find out both. 12 into 7 divide by 22. 12 into 7 divide by 22 is equal to 3.81 nautical miles. You can round it off to 4 nautical miles. So your radius is equal to 1.900 nautical miles, or it is rounded off to 2 nautical miles. Radius of a turn is also easy to be found out. And diameter of a turn. Any questions? Who can tell me what will you do to correct for a slip? Options are correct for a slip. Increase the rate of turn, decrease the rate of turn, or increase the bank angle. What is the correct option? Quick questions. To correct for slip. Option A, increase rate of turn. Option B, decrease rate of turn. And option Charlie, increase bank angle. Chaitanya, answer.
Sir, we'll increase the rate of turn.
Vishnupriya, your answer. Read you one. Nukul, your answer. Muskan, Prerit, Hemant, Suchita, Jyotsna, answers please.
Sir, will increase the rate of turn. Victor
Sir,
Tango, Mike.
option L. Sir, option alpha will increase the rate of turn.
Hemant, Suchita, Jyotsna, Vishnupriya, Nukul.
Sir, option alpha, increase rate of turn.
Correct. Good job, everyone. Chaitanya, good job. Everyone included following the same answer. Good job. Second question. To correct for skid. I need your answers in the chat box immediately. A, B, or C, right? Question number 2. Question number 2, keep it written, and A, B, or C, okay? To correct for skid, increase rate of turn, decrease bank angle, or increase bank angle. Question number 2, Muskan, Roger, Vishnupriya, Roger. I've got your answer. I'll tell you all whether it's correct or not. Suchita, Roger, Prerit. Carefully answer dena hai. Question number 2. These are all confusing questions. What else? Notes में सब कुछ दिया है अभी. सोच समझ के आंसर देना है students. So Jyotsna, waiting for your answer. Chaitanya, cross check your answer. It's opposite of slip, students. How easy should I make it for you? Jyotsna, Roger. Students, go through your notes again. Everything is given to you. Bank angle is low, so you will increase the bank angle in a skid. Bank angle is too low. Rate of turn is high, so rate of turn needs to be decreased. मेरे options में क्या है? सब कुछ सामने तो है. Which is the correct option? Prerit, Chaitanya, why are you giving incorrect answers? अभी ये जो ह्यूमन एरर मिस्टेक कर रहे हो उसको कैसे सही करोगे बताओ. एग्जाम में हो गया तो अब कैसे सही आंसर दे रहे हो मेरे समझाने के बाद. और मैंने क्या समझाया, मैंने तो सिर्फ नोट्स रेफर किया. तो आप लोग भी तो नोट्स रेफर करके क्वेश्चन का आंसर दे सकते हैं ना ऐसे टाइम पे. एंड whoever is not mentioning क्वेश्चन नंबर, आप लोग क्या वीआईपी हो स्टूडेंट्स? ये बढ़िया है. कुछ तो कर रहे हो तुम, बट सिंपल इंस्ट्रक्शन फॉलो नहीं कर रहे हो. हाँ प्रेरित, चैतन्य, व्हाई डिड यू मेक द मिस्टेक? इससे आसान और क्या होना चाहिए बोलो. ओपन.
सर, मैंने नोट्स पे अभी गलत लिख दिया था, तो मैंने भी सही कर दिया.
नोट्स पे गलत लिख दिया. देखो एक सिली एरर अब मैं नहीं चेक करवाता तो कभी चेक ही नहीं होता, ये फालतू में एग्जाम वेस्ट हो जाती ना। अब सोचो कितनी गलतियां होती है। अब नोट्स में क्यों नहीं लिखा है सही से, कोई पूछे तो प्रेरित क्या जवाब दोगे? यू आर अ गुड स्टूडेंट, आई वेरी लेस कंप्लेंट्स, बट क्यों नहीं लिखा सही? अब बोलना अच्छा हैंड राइटिंग नहीं समझ आ रही, तभी कुछ खराब नहीं लिखा है और बोल बोल के सब लिखवाया है। और तुम लोग मुझसे पूछ सकते हो अगर कुछ नहीं समझ रहा तो। वो एक इशू है तो ठीक है, वो भी फिक्स कर देंगे, पूछ लिया करो। Why Prerit did you write it wrong? And Chaitanya, you're not responding quick.
सर शायद जल्दी जल्दी में लिख दिया।
Chaitanya, I'm waiting for a response.
Sir, it was a human error.
क्या थी वो ह्यूमन एरर?
गलती से भी लिख दिया।
वो गलती कैसे हुई वो पूछ रहा हूँ मैं, so that we can avoid it. अब मैं तो वहां पे हूँ नहीं, मैं तो तुम्हें सुन सकता हूँ, तो तुम शब्दों में बोलोगे तो ही समझ आएगा ना मुझे, ताकि मैं तुम्हारी हेल्प कर सकूँ। प्रेरित ने तो बता दिया शायद क्या क्या हो सकता है। गलती क्या है वो तो हमें भी पता है, गलती से ही बी लिखा है, जानबूझ के बी लिखा है वो भी गलती हो गई। पूछ रहा हूँ भाई कैसे हो गई मिस्टेक, सब कुछ तो इतनी इजीली इतने अच्छे से समझा जा रहा है। बोलो बोलो क्या हुआ, जल्दी, लेट्स फिक्स दिस।
की जगह भी लिख दिया बस, टाइपिंग मिस्टेक।
Prerit, Chaitanya, if you are confused, if you have doubts, please clarify. This is the last time. Don't just say anything to cover up a mistake. If you literally have a doubt or a confusion, feel free to ask. बाद में मैं नहीं मिलूंगा ये सब करवाने के लिए, अभी से बोल के रख रहा हूँ। और जब मैं पूछ रहा
नेगेटिव सर।
हूँ जब मैं पूछ रहा हूँ तो मेरे को जवाब नहीं मिल रहे हैं ढंग से। When I'm asking, I'm not getting proper responses. On a left turn, inadequate left rudder will cause slip, skid, coordinated turn. सुचिता, मुस्कान, सोच समझ के आंसर देना है। गुड जॉब इन सबमिटिंग quick answers. Students, on a left hand turn, inadequate left rudder will cause what? Quick. Everyone carefully answer. And be quick. Careful and quick. विष्णुप्रिया क्रॉस चेक, प्रेरित क्रॉस चेक। प्रेरित कुछ बहुत बड़ी गड़बड़ है भाई साहब। विष्णुप्रिया, what are you confused about? I've clearly given to you all students, inadequate rudder will cause slip. Left turn, you apply left rudder only to turn to the left. You apply that rudder which turns in that direction. Right rudder होता तो opposite होता आंसर शायद। So left rudder will cause the aircraft to slip only, students. Inadequate rudder, the rudder which is used for turn in the direction of turn, will always cause you to slip only, students. Why skid? I don't understand. Jyotsna, Vishnupriya, Prerit, why you're making this mistake? It's a left turn. Quickly tell me, students, if you're confused. Students who are not answering, तुम्हारा तो कुछ और ही चल रहा है. Students who have got answer A correct, please be careful and good job. Jyotsna, Vishnupriya, Prerit, what's wrong? Confusion क्या है यहाँ पर?
Answer: in balanced turn, we have written inadequate right rudder applied during right turn causes a slip, and it will be vice versa for skid in the left turn. I have written this point.
So left turn में left rudder ही press होता है, students. Left turn में right inadequate rudder आपको वो effect नहीं देगा जो right turn में right rudder दे रहा है. If it's opposite, then everything is opposite. I made a difference. Be focused on the difference, students. The rudder, you by default, you'll press the rudder in the direction of turn, and that rudder is inadequate in the slip. तो ज्योत्सना आपने ऐसे लिखा कि लेफ्ट टर्न में राइट रडर नहीं देंगे तो वो स्लिप गलत हो गया ना फिर तो वहां पे, बिकॉज ये बीच में मैंने एक पॉइंट जरूरी आपको बोला है. By default, you have applied a rudder in the direction of turn only, just that if it's slipping, the rudder applied is not enough. And if it's skidding, it's too much. But rudder left turn में left ही होगा और right turn में right ही होगा, students. So, Jyotsna, cover up. Tell me, how do you feel about the answer in the question?
Yes, sir, understood, and I will correct it.
Students, मैंने भले ही बोला मिरर इमेज है, बट मैंने लिखा भी तो है ना वहां पे. सब कुछ लिखा भी तो है वहां पे. ये सब राइट टर्न के लिए है, सिर्फ राइट टर्न के लिए. लेफ्ट टर्न के लिए रडर भी लेफ्ट हो जाएगा, स्टूडेंट्स. प्लीज, आई हैव एक्सप्लेन्ड दिस क्लियरली. यू कैन नॉट मिस ऑन टू दिस पॉइंट. Vishnupriya, Prerit, what was your mistake? See, Jyotsna figured out one important incorrect assumption made over there. स्टूडेंट्स, सब चीज मैं लिखा नहीं सकता हूं, आपको समझो. कितनी चीजें मैं बोलता हूं उस पर भी आपको ध्यान देना है. कुछ बच्चे हैं जो नहीं ध्यान देते हैं, उनको मैं कितना मुश्किल से समझा रहा हूँ भाई, जो जो बोल रहा हूँ वो भी जरूरी है. बाकी बच्चे जो अच्छे हैं, अच्छे से सब कुछ इजीली समझते, यू डोंट टेक थिंग्स फॉर ग्रांटेड एंड क्लैरिफाई थिंग्स राइट नाउ. अब मैं ये सिंपल क्वेश्चंस की प्रैक्टिस ना लूं तो कितनी बड़ी कंफ्यूजन हो जाएगी. It's your job to make sure you're not confused. And then come to me stating the confusions if you have. Prerit, फिर से. Vishnupriya, you are giving no response, okay? This is the last time I'm asking you right now. Students, if my microphone is not working from the start of the session, don't you think you should fix it? Answer to question number 4. Students who have given incorrect answers, please drop your correct answers in the chat box. If you have not understood, then discuss doubts. What will you give me as an answer to question number 4? Sushita, good job. Muskan, good job. Chaitanya, wrong.
Your moment is shown by inclinometer, I guess.
Sorry, what?
The yaw moment is shown by inclinometer.
इंक्लिनोमीटर कहाँ लगा होता है?
सर लेकिन इंस्ट्रूमेंट तो अलग है.
किसने बोला इंस्ट्रूमेंट अलग है?
नेम अलग है तो मुझे लगा कि वो भी अलग है.
तुम्हें लगने से क्या होता है? यहाँ पे क्या दिया है आपको ये? यहाँ पे ये क्या है जो बता रहे हैं? वो क्यों नहीं लग रहा है आपको? किधर गया ये? ये पूरे इंस्ट्रूमेंट को टर्न कोऑर्डिनेटर बोलते हैं ना?
ओके सर, अंडरस्टूड.
हम्म। इस चीज पे काम करो चैतन्य. मैं बता तो रहा हूँ, कोई और बता भी नहीं पाएगा. लोग सिर्फ सही आंसर देके छोड़ देंगे. उससे ये हरकत चेंज नहीं होगी. जो दिमाग ऑटो सजेशन, डिल्यूजन और उस पे आर्ग्यूमेंट्स, वो ओवर कॉन्फिडेंस गलत चीज के बेसिस पे वो सबसे डेडली चीज है. मतलब वो हम सोच भी कैसे सकते हैं कि हम किसी से बेहतर हो सकते हैं ऐसी जगहों पर जहां हमें पता होना चाहिए कि हम नहीं हैं. उसमें लॉस किसका है? लॉस हमारा ही है हमेशा. पता नहीं, कुछ लोग दिमाग में बना लेते हैं यार हमको ज्यादा आता है, सर को तो क्या ही आता है. शायद इसलिए नहीं सुनते होंगे. Just because I'm unavailable doesn't mean I'm incompetent. Just because you're available doesn't increase your competency. Mere attendance does not carry results. Turn coordinator, turn and slip indicator, or turn indicator. Turn indicator in itself we are terming as rate of turn indicator. Okay. It uses a, write down the statement, students. Horizontal axis rate gyro with one gimbal and 1 degree of freedom. All right. Now the orientation is pretty simple. If I make these two axes and the third one is a vertical axis like this, okay, then I'll point out this is this axis, this is this axis, and this is up and down. I'll point out as forward, I'll point out as right, and I'll point out as up. So it'll make more sense for you. With respect to this, your gyro, okay, is aligned with this axis, this axis. It rotates around this axis and it rotates in this direction. I'll show you the direction also, wait. Now, in one of the questions, you will see that the rotor, it rotates up and away from the pilot. Up means it is rotating upwards, and away means it is going towards the window. So a pilot is seated here in the cockpit of the aircraft, like this. This is the eyesight, okay? And here are the control columns. So gyro is aligned like this, where I can just how your cycle or bicycle or car wheels are aligned with your forward motion, your gyro is also rotating like that only in the same line. Okay. Now, if you see, there is just one gimbal. Okay. So it will have a frame like this on the four sides. And here you will have your needle, and here you can have your scale, upside or bottom side or above side. Now, very simply, with respect to the forces acting, if this frame in itself, horizontal frame, along with the gyro, precession, everything, rotates right or left, and the pointer is attached to the frame only, and it moves in the direction of turn only. So the frame, due to precession, it moves. Precession is primary and secondary. Primary is with any torque that it generates when you're turning right or left. And secondary is with a spring. The spring is attached to the fixed structure of the instrument. Now this spring adds to the precession value, adds to the torque, and the movement of the spring whenever the aircraft is turning and precession is happening, the movement of the spring then shows you the rate of the turn, which is realistic. If there would have not been a spring, you would have not gotten an instrument reading as accurate as a rate of turn indicator based upon the gyro used. Now this rotor can be vacuum, air vacuum, pneumatic vacuum, okay, or it could be electrically driven. Because the RPM is not, the requirement of RPM is not too high. Why? Because it works on precession. We need more precession. So a pneumatic air-driven, engine-driven air or vacuum pump is enough to drive your rotor. You need more precession. The spring is claimed to be related to your rate of turn. The movement of the spring defines it. The spring gives you secondary torque, the force of the spring. If there would have not been the spring, we would have not got the controlled rate of turn. Okay. When you will be reading through the text, just read through the mechanism once, or you can avoid the mechanism if you understand these basic points. Okay. With respect to your CPL syllabus, of course. Rate of turn about a vertical axis. Do not confuse the vertical axis with respect to gyro axis and all. That's aircraft's vertical axis. Turn will be measured about vertical axis only. So that is a given. The rotor turns up plus away from the pilot. Remember that up and away, it moves in the forward direction, that the rotor. And the cage, not the cage, the frame will move in the direction of the turn only in the end. So the tilt of the gimbal will show you the direction of the turn. As simple as that. So miniature aircraft is also fitted with that only. Now, with respect to your turn coordinator, okay. So here write down important note first, couple of key points. The tilt or the angle of tilt, okay, the angle of tilt of the gimbal measures the rate of turn. Now a pointer fixed or linked with this gimbal indicates the tilt on a scale on the face of the instrument. The scale is indicated or the scale is calibrated to indicate rate of turn either side of the zero, where the first graduation will relate to rate 1 turn. Aircraft will be 3 degrees per second. Second graduation could be rate 2 turn, 6 degrees per second, and so on. Calibration for correct rate of turn. Okay. Calibration of correct rate of turn. All right. In bracket right, can be achieved by regulating spring tension. So initially when the instrument is fitted, it is calibrated. It is calibrated for design TAS, or it is calibrated for a fixed TAS of an aircraft. In simple words, you have to have the keyword as TAS and calibration, spring tension and TAS. Error with respect to TSI, turn and speed in turn and slip indicators are not too high. Okay. Errors are very less. Errors are 5% over speed range of 85 knots to 350 knots. And average speed measured is 260 knots. Just keywords you will be on the lookout when reading the text. Remember, the rotor RPM can be low because this gyro depends upon precession and higher rigidity is undesirable. The precession or the rotor RPM in a TSI, TC is lower than the one used in DGI and AH because there we need rigidity, here we don't need rigidity. Now, of course, damping systems are also used. Damping systems will also be used. They have mentioned the damping systems could be piston and cylinder type or electromagnetic type. Just remember the keywords. Okay. Eventually you will learn when you do technical and all, you will learn what these are if you don't know otherwise, like piston and cylinder type. There's a cylinder piston used to damp out the undesired motions of the gimbal. A keyword is a stop limit is applicable, or stops, mechanical stops are there in the frame and the gimbal mechanism, where the gimbal tilt corresponding to a turn of about 20 degrees per second, 20 degrees per second, you have stops to prevent gimbal from moving further. So there are mechanical stops in the gimbal system. Just key points that you need to understand about the principle of construction. Okay. There is an important note in the textbook given to you. There is only one gimbal. The gyro will not topple when it comes against the stops. Will not topple. Will not topple. Do only one gimbal or gimbal. Now, interesting thing is gyro rotor speed should be low. When the rotor speed is less, or when the rotor speed is more than the usual. Generally, it should be lower than DGI, AH, we know. But when the rotor speed is less than required or more than required. If rotor speed is less than required, it means your gyro is under speeding. Okay. And it means the instrument will under read the turn rate. It means rate of turn is higher than indicated. All of a sudden, we are talking about a TSI under reading and overreading, or a turn coordinator under reading and overreading. Now, what can happen at higher altitudes, or when your filter for the air pump is choked, or the suction tube that is carrying the suction to move the rotor is leaking? Then the rotor will be not moving at an RPM that was required for it to move. So it is under speeding. When rotor RPM is not enough, your rate gyro measured for rate of turn will underread. It means you will have an excess rate of turn for the said reading that you want. So you don't need that. You need it to be coordinated, in simple words. So sometimes it might not be in your control if the rotor in itself is not moving accurately. So overreading, underreading is associated with the rotor speed. Similarly, lower altitudes or getting excess push in the air, excess dynamic air, whatever, so anything extra that is increasing the pace more than required. So the rotor will be overspeeding. And what will happen when the rotor will overspeed? It will overread the rate of turn. Overread the turn rate. It means rate of turn is lower than required or than indicated. Overreads rate of turn is lower than indicated. So this is very tricky because in the exam questions are given like this, but the material is given like this. So rate of turn is higher than indicated. It means under reading. Overreading means rate of turn is lower than indicated. So indicated is higher, only then it will mean overread. So it's just word play. Okay. There are key points in the looping plane, errors in looping plane, but we don't have to cover that. So if you are reading through the textbook talking about errors in looping plane, just write down the takeaways. Like a positive movement in the looping plane will make the indicator to overread, like that. But it is not important for you, but it is not that difficult also. Then you come across slip indicator, read the points. When your ball is balanced in the center, it means your bank angle is correct for that task and the rate of turn. To increase or decrease, you can play with the rudders. We have already seen that. What would be the accurate bank angle for rate 1 turn? You know that. The inclinometer is known as ball in tube inclinometer. And remember, with respect to this inclinometer, the design is such that the center of the ball fits perfectly with the center of the tube here inside. And the ball putting a force down and the center of the tube putting a force up are balanced in each other. For ATPL, you will be studying this any which ways. So a slip indicator is known as an indicator that will give direct indication of the state of a balanced turn. The slip indicator is a part of turn coordinator or part of a rate of turn indicator. So your rate of turn indicator will show you roll and yaw both in a different way. But yes, yaw is shown through inclinometer only, right? And roll, of course, bank angle rate of turn. So it's vice versa. Like, don't get confused over there with respect to certain things. Inside a turn coordinator or rate of turn indicator, gyro is used to measure rate of turn, horizontal axis, 1 gimbal, 1 degree freedom, gyro, rate gyro, and inclinometer to give me a balanced turn or to show me whether the state of balance of my turn is perfect or not, or whether my turn is coordinated or not. You can skip operating principles of the ball inside. Just remember the aircraft weight and lift forces during a turn, including the centrifugal forces, they are parallel to the forces in the inclinometer on the ball. That's why the ball is a good indication of what the aircraft is going through. In a balanced turn, the aircraft vertical be in the same line with respect to the ball vertical in the inclinometer. A simple point, remember, yeah, they are parallel, they are in the same line. If too much bank is applied, too much bank, the tube, forget the tube, when too much bank is applied, what will happen? Will the aircraft will be slipping in or the aircraft will be skidding out? Too much bank. Hemant, care to give me an answer? Too much bank? Suchita, too much bank? Prerit?
Will slip.
Slip.
Sir, it will slip.
Too much bank, slip. So simple words. Applying too much of bank, slip. What to do when you are slipping? Too much of bank, left direction, slipping. Apply left rudder. So too much of bank would mean my left rudder is inadequate. One more relationship taken out. Bank, students, is based upon you bending the ailerons, like playing with the ailerons, right and left. Too much bank would mean you have not compensated the bank with adequate rudder. If you're turning left, too much bank to the left, you are slipping in. Apply adequate rudder, bank would reduce, yaw would increase, and your turn would be good enough. If I don't apply the rudder, too much bank will make me turn, but it is not safe for the aircraft. The aircraft is slipping. It means, so slipping inside, it means it could deviate off track in the long run. So too much of bank angle slipping in means less of rudder applied. So what would cause slip? Too much of bank angle would cause slip. Less of bank angle would cause skid. The same thing, the same things that we saw again in 4 questions that we practice right now. On the chat, everybody giving me correct answers. Turn coordinator is just an advancement. Remember, in the turn coordinator, the primary difference between a normal rate of turn indicator and a turn coordinator is the setting of the precession axis of the rate gyroscope and the method of display. Setting of the precession axis. So axis will be of anything and everything, axis of rotor, axis of precession, this and that. So the setting of the precession axis of the rotor of the gyro and the method of display. Those are the 2 differences. So the precession axis is 30 degrees. Precession axis is 30 degrees with respect to aircraft longitudinal axis in a turn coordinator. In turn coordinator, precession axis is 30 degrees with respect to longitudinal axis. It's not in line with the longitudinal axis. It's 30 degrees to the longitudinal axis, which makes the gyro sensitive to the aircraft banking as well as turning. Now, how do you turn, students? You turn by banking the aircraft in the direction of turn. When you bank the aircraft towards right in a right turn, the gyroscope will precess. In this, it will move the aircraft symbol to show the direction of bank, and you will be easily able to anticipate the turn. Basically, it leads you to take a perfect turn, the turn coordinator, by making the aircraft too sensitive, giving you super instantaneous values. Now, with respect to the graduations on the scale, you can turn the aircraft, rate 1, rate 2, whatever instrument you are using. Generally, all instruments will be 3 degrees per second for rate 1, unless otherwise. Remember, there will be no pitch information mentioned on your rate coordinators, turn coordinators. Turn and slip indicators don't have it, but turn coordinators have it. And do not get confused thinking it's an artificial horizon. So if I have to ask you, a turn coordinator has how many gimbal rings pivoted, and in what way are they pivoted? So let me ask you this question. A turn coordinator has 2 gimbal rings pivoted in orthogonally in the case, or a turn coordinator has 1 single gimbal ring pivoted longitudinally in the case. A turn coordinator has 1 gimbal ring pivoted laterally in the case, and a turn coordinator has 2 gimbal rings which are mutually perpendicular to each other. So you know the answer here will be single gimbal ring. But which one? Longitudinally or laterally? Think. You're always confused with these terms. Muskan, Jyotsna, very good. It's longitudinal axis, students. You saw the diagram. The option is a turn coordinator has 1 single gimbal ring pivoted longitudinally in the case, aligned with the longitudinal, but 30-degree offset with the longitudinal in turn coordinator. Remember that. Otherwise, aligned with the longitudinal is true for all turn coordinators or rate of turn indicators. A 2-minute turn. So I'll give you an indication right now. Okay, quickly. It's a turn coordinator. And your aircraft is looking like this. Okay. And in your inclinometer, your ball is here. And it's mentioned it's 2 minutes like this to show you what the graduations mean. Now look at the symbol, everyone. This is your question number 2 for now. And tell me, if the aircraft is turning as indicated, then what does it mean? Option A, aircraft will turn through 180 degrees in 2 minutes. Do you think the aircraft is going to turn 180 degrees in 2 minutes? I don't think so, because 2 minutes mean 360 with respect to turn coordinator. So questioner, option 1 is gone. Option 2, it will take 1 minute to turn through 90 degrees. 1 minute to turn through 180 degrees is what I know. So no. Third option is the aircraft is turning left at less than 3 degrees per second. And the fourth option is the aircraft is turning left at 3 degrees per second. Remember, slipping Bank angle is high, rate of turn is low. Left turn, the ball is in the left, it's slipping. It means its rate of turn is lesser than 3 degrees per second. So option Charlie seems to be the correct. Option Delta, aircraft is turning left at 360 at 3 degrees per second, would have been right if my ball would have been in the center. But because ball is slipping bank angle high, rate of turn lower than 3 degree per second is the correct answer. Question number 2, Charlie 3 is the correct option. Following students, everything. I hope I'm not going too fast. Almost done. One more question. I am asking y'all. Simple, okay? A gimbal ring of a turn coordinator. Thanks for the acknowledgement, students. 3-4 log ne diya, अच्छा लगा मेरे को. A gimbal ring of a turn coordinator is inclined at about 30 degrees with respect to aircraft's longitudinal axis in order to. Option A, make the rate of turn more accurate. Option B, make the gyro sensitive to banking of the aircraft as well as to turning. Option C, make the gyro more effective during inverted flight. Option D, have a higher rotor speed which will prolong the life of the instrument. Anybody wants a read back of the definitions? I don't know.
Bravo.
Bravo is correct. Very good. Make the gyro sensitive to banking of the aircraft as well as turning. Very simple. Let me ask you one more question. A rate of turn indicator uses a dash gyro which spins dash. Uses a rate gyro which spins up and away from the pilot. Not a space gyro, not a tight gyro. A gyro in a rate of turn indicator has dash operating speed than the gyros used in other instruments because it has a lower operating speed because a higher rigidity is not required, or it has the same rotor speed. No. It has a higher rotor speed. No. It has a variable rotor speed, but that is because more than one rate of turn is required or desired. No. It is lower because high rigidity is not required. We need more precision. That's the correct answer. So be very careful with these points. You don't have to solve the question. You need to remember the points. Now take the same example. Okay? The turn and bank indicator. It's a turn coordinator, also called as turn and bank indicator. So now we know if Chaitanya was asking, sir, turn and slip. The turn and slip indicator will be a specific name given to the needle. Turn and bank indicator is a common word given to turn and slip indicator or turn coordinator. Now that is a conclusion I can come wrapping up the session to that particular point. What is the common word? Turn and bank indicator is the common term. It's fine though. It's the same almost. What is this indicating? Is it indicating a rate of turn to the left, slipping in? Is it indicating an aircraft is taxing and turning to the starboard? Is it indicating that the aircraft will complete a turn in 1 minute? Or is it indicating the aircraft is yawing to the right? I think a rate of turn to the left, slipping in is the correct answer. What do you think? Of course, turning left, rate of turn left, 2 minute turn, 2 minute 360-degree turn, slipping in. I can also say inadequate rudder applied, too much bank applied, low rate of turn applied. 3 things could be said. How to come out of this? Press more rudder, reduce the bank angle, or increase the rate of turn. Simple. This quick understanding is very simple. Very important. Now, one last point I want to read. Radius we were able to find out. 2 points. Now, if the filter of an air-driven rate of turn indicator becomes partially blocked. Filter becomes partially blocked. You know, underspeeding of the rotor. Underspeeding of the rotor will cause the rotor to underread. It means the actual rate of turn will be higher than the one indicated. Now look at the question. The filter becomes partially blocked. What will happen? Option A, aircraft will turn faster than indicated. It means rate of turn will be faster or higher than the indicated. But the value they are saying aircraft will turn faster indicated. Student like aircraft kaise ghumega instrument se? But they're trying to say that the aircraft turns with a higher rate of turn than indicated. Second option, the instrument will overread. We know it's under speeding, so it will not overread. It will underread only. That is directly proportional. The rate of turn indicated will be unaffected. Not really. The radius of the turn will decrease. Radius of the turn will not decrease. Why? Because your rate of turn, answer is A, aircraft will turn faster than indicated, means aircraft is under reading. Simple. Radius of turn will decrease is associated with slip. When aircraft is slipping, the ball is going towards the center. It means the radius of turn is reducing. Skidding, increase in the radius of turn. So add this one more point. Flip, radius of turn decreases. Last rule of thumb. And skid, this is with respect to the radius of the turn, which we just found out using the circumference speed relationship. Skid, radius of turn increases. Remember these terms with respect to radius of turn as well. Okay. One final point with respect to construction, and we are done. When a pointer of a rate of turn indicates, or rate of turn indicator shows a steady rate of turn, pointer, needle type. So what happens? The spring is providing a force which produces a precession equal to the rate of turn in the correct direction. The spring provides a force which produces a precession equal to the rate of turn in the opposite direction. No, the spring gives us a secondary precession or the torque that completes the direct relationship between the moment and the actual turn in the direction of turn. So with respect to that statement, the first statement said seems correct because it's in the correct direction always. Wherever the tilt is happening, the turn is in the same direction. It corresponds everything. It just copy pastes the aircraft movements with respect to the horizon, with respect to slight rigidity that you have maintained with the aircraft. They're also claiming the answer could be the force produced by the spring is producing a precession equal to but opposite to the rate of turn. Is correctly banked. No, it is not like that. It is in the same direction. One more option that can confuse you would be the calibrated spring is exerting a force about the lateral axis equal to the rate of turn. No, nothing like that. It's about the longitudinal axis is something that could be said. But that is not the case here. The correct answer is the spring provides a force which produces precession equal to the rate of turn. So the primary precession combined with the spring secondary precession overall gives me a precession force that will tilt my gimbal, and the force will be equal to the rate of turn in the correct direction as measured along the indicator and shown on the instrument face. It is pretty simple. Read just once, appear for the test. Prepare for the worst case scenario. I'll be covering more such topics quickly, nicely for you to know if there is anything wrong or pending. Please make sure as you go ahead, you are marking out one pointer as you go ahead. You should not, when you're attending these sessions, these things should not miss in the exams over and above anything else that you're learning. And your personal growth with respect to where you stand, where you're going to be, keep sharing the list and updates with me, students, so that we can target the session, study nicely clear. We have enough time right now. If we go with the strategy, they have worked on the basis. Your fundamentals are strong. You have studied so much, so many hours. If you think about it, you're just polishing things and training with respect to high level scenarios. That's it. You do this much and you are ready to score well if you are conscious with respect to the use of your logic. Your logic will be based upon all the clarity in the fundamentals that you have. I have got a list yesterday which has a few points on which we have not done live sessions, like vertex, great circle vertices. I said I'll be doing separately. Other than that, everything is covered. GC, LAD, D, long departure. Great circle vertices. So that list is very important that you have, students. So keep sharing with me on a regular basis so that I can inculcate a few individual topics in live sessions as we go ahead in real time. So whatever you think you have not done and whatever you think you need a session on, it will be better if that is there in the list and the same list is shared every day with me or generally after every session. Any questions? Apart from sir, आज break क्यों नहीं दिया? Any questions? Anybody smiling on the joke? Or did I touch? Did I sprinkle salt on your wounds? I'm not sure. I hope I've done nothing of that sort. Remember, it's tricky, it's highly scoring. Gyro, overall finish gyro ASAP. DG and some other thing is there with that. Just finish it and be ready. So that slow and steady, you can finish one small sect and get done with it. I'll be seeing you tomorrow, students. First, I'll be giving you a test to do. Perform well, score 20. And you'll get questions similar to how AH questions were. Don't copy, don't do shortcut. Cheating and scoring well in these tests will just make you have ratified these questions. And the same questions repeat, you'll be able to answer. But if similar questions with different values come, what's the guarantee? So try to solve so that if you're wrong, you can discuss with me, like we discussed so many questions for 1/60, right? And stay in sync, everyday effort, so that these new lectures are not a backlog for you. Because I need your live interaction here so that you can discuss live in class whatever doubts you have. No more questions for me, is it? Good. Remember, we have not just studied from Oxford, we have studied from quite a books to make it such more simple. But core is the Oxford textbooks only for now. So if you reading through it once also will give you high advantage. And it's not a joke. It's good. It's a collection of good material all across the globe. But a few things which we cannot directly infer, now we have that info. So your notes that you have made today, make sure they are correct. Remember the concept, right turn, right rudder is by default applied. It's just that if I'm slipping, I need to apply more right rudder. If I'm skidding, I need to apply less right rudder. How to apply less right rudder? By counteracting with the left rudder in a right turn, left turn, simple. Turn coordinator is one of the most easiest of all instruments. Do a good brief and let me know if you're stuck somewhere, okay? Students who have missed lectures, you know the playlist save kar lo. Regulations is B22 Prerit. You go in the playlist, you'll find the section that you missed. So I don't need to separately give your links because I know whoever is missing, I'm keeping the session open only. I'll do it once students are done studying online. So it's still open. You can access it. If you cannot access it, share with me. But you should
Sir.
automatically be able to access it, okay? So that there's no delay in your access. Students, you have a big thing to do. You have to do thorough revision of about 70 lectures studied and discuss if you have any doubts. It's not a piece of cake. Okay? Make sure you communicate well and just be happy and be positive, okay? Chalo students, I'll see you when I see you. Impress me more with your results. and don't take anything for granted. Avoid human errors, silly mistakes as much as you can, and you will see you're getting 5 to 8 grace marks in the exam extra than what you would generally get. And that makes the entire difference in the exam, students. Okay, chalo. Thank you very much. You can leave now, students. I'll leave after you all.
Thank you, sir. Bye-bye.
Thank you, sir.
Most
Thank you,
welcome.
sir.
everyone.
Thank you, sir.
Most welcome.